Cool, today we're going to talk about parser combinators in PureScript. As always, if you know how to read Haskell, this is going to be easy to follow. Also, the idea here is that we are going to build a super simple library that allows us to parse things out of strings in a way that each piece is super composable with everything else. Okay, let's start from the data type. We have a parser which parses a value of type A out of a string. So, as we said, we start from a string, and the way the parser works is that it could fail, so in case of failure we will be using nothing. If it succeeds, it's going to be a just of the remaining string after the parsing succeeded, and the intermediate result, which is what was parsed from the original string. Then we need to be able to run the parser, so we have this simple function which extracts the parsing function out of our parser, and it accepts a string that needs to be parsed, and it just runs the parsing function against the string that we want to parse. Now, this is a parser combinator library, so keyword combinator, meaning that we are going to be needing to compose pieces together. The way we are going to do it is that we're going to be using monad. And for that reason, we have the instances of parser for all of the type classes up to monad. They are not shown here. If you want to dig deeper, go into the description of the video. There's a more in-depth explanation of that. Okay, we are ready for the cool part. So the first parser that we can define, which is the simplest one, is a parser that always fails. Now, of course, as of now, it doesn't really seem to make a lot of sense, but bear with me for a second. So this is simple. We just build this parser with a function that no matter what's the input, it's always going to return nothing, which is our way of signaling a failure in parsing. Now let's get into something slightly more useful. So here we want to have a parser that is capable of parsing any char. So for example, if we decided to run any char on the string, we would get out as an intermediate result the character s, and the remaining string would be string. Okay, but how does any char work? So the idea is that it's a parser of char. We saw the char part because the intermediate result before was the character s. Now it's a parser that takes a string, and the way it works is that it first transforms a string into a list of characters. This is needed in PureScript. If the list is empty, meaning the string was empty, we return nothing. We failed because we couldn't parse any character. If we have at least one element in there, we return a tuple that, as an intermediate result, has the head of the list, so the first character in the string, and the remaining string to parse is all of the remaining characters. But let's step our game up just a bit. So here we have two new parsers. One is char, which tries to parse one specific character. The other one is digit. Now, you can see how it works, that if we try to parse s out of string, we get a successful result. If we try to parse capital Z out of string, we fail. And digit, of course, does what's expected, which means it tries to parse a digit from the beginning of the string. Get ready for something cool, but on the next slide. This is an intermediate step. So we first define a parser that is called sat, which allows us to parse any character that satisfies a predicate. Now, notice that we are using the monad instance here, which means that in case this line here fails, for example, because the string is empty, then we would not even evaluate that line. If this parser succeeds, we extract the intermediate result, which is the parsed character, and we see if it satisfies the predicate. If it does, we successfully parse by using the applicative instance of Parser because of Pure, otherwise we fail. And this is where it gets interesting. So we can use SAT to define a ton of new parsers that are super useful. So we can define digit to parse a digit, a parser to parse lowercase characters, uppercase characters, a letter, an alphanumeric character, or a specific character. And of course, we don't want to parse a string character by character. Sometimes it will be useful to just say that we want to parse a string out of a bigger string, so we can define a string parser. Let's see how string is implemented. So we want to parse s out of the original string. We first transform s into a list of characters, which means we can find ourselves in two cases. The first one is where the list is empty. The second one is where we have at least one element. If we have at least one element, we try to parse that character, and then we recursively call string with the remaining characters to parse. If both of these are successful, it means that we were able to parse the list of characters that has as head x and as tail xs. If at any point in the recursive calls we get to a point where s is empty, it means we finished parsing the entire s, so we return the empty list because here we were returning a list. Right? So here we have a parser of list of characters, but here we need a parser of string, so we use the functor instance and we map from chars, which transforms parser of list of characters to parser of string. Well, it took me a ton of takes to explain the string parser. I hope I did a good enough job explaining that. So this is all for today. I'm going to follow up with another video building on top of these foundations. Again, in the video description, you can find more information. As always, thank you very much for all of the subscriptions, the DMs, the comments, the emails, everything you do to get in touch with me. I really appreciate that. I'll see you next time.